Welcome back, Math 2 crew. This is Mr. Jacobs. I'm looking at section 8.8, page 468, and we're going to work out a question on completing the square application type problem. It also discusses something called vertex form of a quadratic, and we have not talked about that, but what it does is it allows you to find the vertex of a quadratic when graphed by just looking at the form of the equation. So let's start. A model rocket is launched from a 12-foot platform with an initial upward velocity of 64 feet per second. Write a quadratic function in standard form that models the height of the rocket. Now, the quadratic that models height of this type of motion is given here. It's projectile motion. And there is the quadratic equation that describes projectile motion under these given conditions. So I will write that down. Here. The height of the rocket at a given time is equal to negative 16 t squared. The first term represents the acceleration of the rocket due to gravity. So that's negative 16 feet per second squared. That means it's falling at 16 feet per second and accelerating at 16 feet per second every second. Plus the velocity of the rocket, and it's an initial velocity. It's given that velocity, and then it no longer has that velocity. It stops. It's just one quick blast. So that's the initial velocity of the rocket moving upward. That's the second term. Plus the starting height of the rocket, which is h sub 0. And so let's substitute. We're given the initial upward velocity of 64 feet per second. So v, 64 feet per second. And the height of the rocket before it's launched is 12 feet. And so let's substitute. So this becomes and so there is the quadratic equation in standard form. It's the quadratic function in standard form. Now it says write the quadratic function in vertex form that models the height of the rocket. Now we've never talked about this, but there is a form of a quadratic that shows you the vertex of the quadratic when graphed. And so how you find this vertex form is by completing the square. And these are one of the reasons why we do that. So I'm going to run out of room, so I'm going to have to move my information over to the right to show this work. So I'm going to move all this over. Okay. Now, so let's write down this information. It was negative h of t equals negative 16 t squared plus, was it 64? Double check. Yeah, 64 and 12. So to complete the square, we have to just isolate the first two variables. And also, t squared must have a coefficient of 1, not negative 16. So we're going to do a couple of things all at once. I'm going to move the 12 over to the right side, and I'm going to divide by negative 16. So we'll do this all at once. 12 is going to move over to the left side. So let's divide everything by negative 16. And again, I'm completing the square. And so, this is reduced. It becomes 3/4, right? It's going to be negative 3/4. So I'll move that over. It becomes positive 3/4. I'm going to write this as plus give myself some room. Okay, now let's take half the middle term, half of 4, and I want to make sure that this is, we see that this is negative 4 because negative 16 goes into 64, negative 4 times, so forget that negative sign. And then we square negative 2, and that gives us positive 4. So we add positive 4 to each side. Okay. Now, what I see here is this becomes t minus 2 squared. Okay. And over here, at 16, I really do want to get rid of it, and I am. So let me just straighten this up here. Negative 16 is messing everything up. So what you do essentially is you're going to take all of this whole expression there, and we're going to multiply it all by 16. And so if I multiply the left side by 16, I have to multiply the right side. So we're going to show the work. And I'm just going to kind of cheat here, so don't get too freaked out. But instead of rewriting this, I'm just going to move it down. Okay? You might have to write it again, but I'm not. I have a digital copy. So I'll multiply everything here by negative 16. Okay? And this is what happens. That becomes negative 16 times 4 is negative 64, right? Yeah. And let's multiply this by negative 16. Now, be careful, because 3/4 times negative 16, the 4 divides into the 16, so it's negative 4. And negative 4 times 3 is negative 12. And then here, negative 16 times h of t over negative 16, well, the negative 16 reduced to 1, so that's just h of t. And you multiply this also way over here by negative 16. So cleaning all this up, negative 64 plus negative 12 is negative 76. And when that's moved over to the right side, you end up with h sub t equals negative 16 times t minus 2 squared plus 76. This is the vertex form of your quadratic. And what that means is that the vertex of a quadratic equation, when graphed, is positive 2, comma, 76. And we haven't talked about it, but the term inside the parentheses, the constant, its sign switches. Okay, so that would be the vertex. So slide all the way over. And we're going to write that. So negative 16, negative 2, and 76. Negative 16, negative 2, 76. Oh, 76. So it says graph the function. So I'm going to graph this using GeoGebra. I just want to make sure that we see what's going on. But this vertex positive 276 would be here, approximately, right? This is 80, this is 75, 76 probably there. We know that in standard form, the last term is where the graph crosses the y-axis, right? When time is 0. That would be, well, about here, right? And then we know that all quadratics have, one graph, have a line of symmetry, and this line of symmetry would be here, right? Right? And so we can tell that, sketching this diagram, that if the distance from the line of symmetry to this point on the y-axis, the y-intercept, is 1, 2, 3, 4, then moving over in the opposite direction, 1, 2, 3, 4, again, 1, 2, 3, 4, up 12 is also part of your graph here. So here's what this would look like as a sketch. And again, my sketches they are not that great, so let's see if I have a special sketch tool. Yeah, I don't. But let's give it a shot. Let's try this. So I'm thicken my line up. Make it a little transparent. Let's go Verde. And so here we go. Yeah, not very good. But that would be the graph of this function, drawing it freehand, using just 3 points. So let's use GeoGebra and see what that looks like. So I know what the function is, right? Negative 16, negative 2, and 76. I think I can remember that. Just remember that we're using y and x, or h and x. So let's see how this works. So here we go. H of x, go large, equals negative 16, it's x minus 2 squared plus 76. Okay, when I graph that, I don't see the top of the graph. So I'll just change my y scale by using Shift, Alt, and dragging the y-axis and moving it down. And I'll also show the grid. Okay. And maybe Shift, Alt on the x-axis to stretch this out. And there we go. So there's the graph. I can also import that if I'd like to in my presentation, but I won't. And so you can tell if I were to pick points. Let's see, let's go to intersection. See where this intersects right here. There we go, and there it is. It says that number 12, again, was the y-intercept. The y-coordinate is 12. Let's see what the x-intercept was. Oh, yeah, okay. It says that it's 4.18. That's the x-intercept. Okay. And so if I were to want to see the label, I'd go show label. Oops, wrong button. Well, anyway, I could, but I'm not. Okay, so we see it here. Going back to the question, we graphed it. It says state the domain and range of the function in the context of the situation. So the situation is that a rocket has gone up and down. At the starting time, you start at 0 seconds, and then the clock begins. So even though the parabola, when graphed, looks like it does have a time that exists in the negative x coordinates, that doesn't work in this situation. Let's look at here. See, you're in the negative range here when you look at your x coordinates, but there's no such thing as negative time. So we know that we're going to start at 0 seconds, and then we move to the right in terms of seconds, and about 4.18 seconds, the rocket hits the ground and it stops. There's no movement anymore, right? So I would say my domain, this is what you're going to write, Your domain is, and again, I'm not sure when's the last time you had an opportunity to talk about domain and range, so you might be a little rusty, but here's how you would write this. You would write the domain, since I'm out of room, I'll write it up here. Choose my normal pen. Is between 0 and 4.18 seconds. And so we're talking about time. And so that's how you write that. It's called a compound inequality. And so between 0 and 4.18 seconds. That's your domain. Now, your range is dealing with height in feet of the rocket. So with that said, if you look at the height, the maximum height is 76 feet. And then the minimum height is 0 feet. So your range is similar. In that we know it's going to hit rock bottom at 0 feet. And we're going to call that h of x. And then, of course, the maximum height is 76 feet. And again, that's called a compound inequality. I'm not quite sure if you remember writing something like that, but you have a range of values, a minimum and a maximum. And those are the possible values for your height in feet, and these are the possible values of time in seconds. So I hope that helped a lot. Remember, like I always say, study hard and learn a lot, and we'll see you soon. Bye-bye.